What's good, guys? Welcome back to the channel. So today we're starting a really cool job. We're going to be here for a few weeks. There'll be a few videos, might be a series or something like that. We're back at the place where we did the cable joint in. So the landlord's getting a hold of the place now after what happened. Trying to get a hold of the electrics too and all that sort of stuff. So we're here today to start our works here. So one of the jobs is an MCCB board being installed in here, all new mains and stuff like that. So that's going to be really cool to show you. And we're also doing work in some of the units to bring them up to compliance, make them safe, and just get them to a workable standard. A lot of it was just gutted by UKPN. Just because that's what they do, and they just cut it all out regardless. So we've got to reinstate a few bits and stuff as well. In here we are doing this panel board because we were originally going to replace this just because it's in a really bad way, and because it's all exposed inside. Even if you turn it off via the main switch so that you can work in the top half of the panel, once you remove all the covers, the whole bottom half, you know, the 2000 amp pads and the incomers and all that stuff, is just all exposed and live. So you have to get UKPN out every time you want to work on it, and it's just a nightmare. It's not maintainable, it's not you know, cost effective, it's just a bad idea all round. So yeah, we originally went in to get a proper segregated panel where you could isolate the main switch, still work within it. They were coming out at like 25, 22 grand, just ridiculous prices. So you know, we're talking 2000 amp ACBs, custom boards, metering and all that sort of stuff, so you can imagine it gets really expensive. So the client didn't opt for that. We've offered them a cheap alternative of putting an MCCB board within here, which will come off of this board, but once we divert everything through our MCCB board, you can isolate that safely, you can work within that safely, and this can just stay feeding it and yeah, stay how it is. Obviously once it's powered down, we're going to try and plug all of the holes that we can, sort it out as much as we can, and make it safe. We've got like where, because you can't work in it live, people open these side panels, and to strip out a supply, they just cut the cables off and leave the breaker off, because that's, although completely rough, not acceptable whatsoever. They find that safer than taking the cover of the board off to disconnect the cables, just because it's all exposed there. So once we can get it off, we're going to sort it out as much as we can and get it back to you know, a decent, well, yeah, a compliant standard, should I say. So yeah, today is the first day of the job. Like I said, it's going to be a bit of a series, but today's video is going to be validating these existing sub-mains, validating wiring and stuff like that, drawing a temporary schematic for the mains and all that sort of stuff, doing some cable calcs and stuff like that, because we're pretty sure these sub-mains are going to fail. They're just way too long. They're pretty small, and they ain't got a chance of passing. So we might have to look at going from our MCCBs to BS88s and stuff like that, just to get the ZS times to pass, basically the ZS values to pass, sorry, for trip time. So yeah, there's going to be a bit of that. I'm going to show you planning this board as well, how we're going to do the trunking, working all that out, ordering materials and just all that sort of stuff. If you haven't already, please like, subscribe and hit that bell button, and yeah, let's get to it. Right, so this is the mains room that we're going to be working in. That's where our MCCB board is going to go. It's a Hager board. So I'm thinking like a 6-inch trunking set off uni, coming round high level, dropping down either side or one side of the board along the bottom, so we can bottom entry the tails, probably send it through all the way at the top with an end cap on, maybe return it round. This is UKPN metering, so we can't move any of that. These are a couple of sub-mains. There's also another one under there which you're going to have to take out torpedo and get into the board as well. But these two are just taken around here and then really poorly just like twisted on themselves there. So I'm thinking we'll lock them off. We'll lock the ducting off, sorry, not the cables. We'll fit some galvanised tray up here, core hole through, tie them up nicely, and then they can come through here along into the header trunking, ready to be put away into the board. So that'll be that. Then we need to cable calc it, but I think Pro Design, Amtech Trimble Pro Design was coming in at 150 parallels, so we're probably going to do that in tri-rated, 150 parallels up the trunking round and in, and then we're going into this 600 amp magnetic, thermal magnetic circuit breaker, MCCB. So that currently does this power factor correction unit, which isn't working. It hasn't worked for ages. So that's going to get stripped out. We'll look at potentially reintroducing one of them, although I don't think it's probably necessary now. It was a old sawmill, so you had a lot of inefficient loads and stuff like that, but now we'll have to see, you know, one, if the client wants to pay for one, and two, if it's even necessary. But yeah, then yeah, we're gonna go into this breaker up here. Luckily it's got three terminals to accept for each phase, so we can have our parallels going in there nicely. That will all come out and what have you. And then that's what I was on about before. So these breakers are off, but they've just chopped the cables off and taped them up, because in there you've got exposed buzz bars. So to take this cover off, to take them out, is just far too dangerous. Not that that's any safer whatsoever either. The panel should be isolated, they should be disconnected properly. But yeah, that's what you're dealing with. That's the problems that arise out of having this situation where you've got to call UKPN out to isolate it. And that's what we're trying to negate by putting this panel in, just that people can maintain it and work on it properly and not be forced or feel like they're forced into situations like that. Because UKPN aren't cheap to call out. Not that that's an excuse, not at all, but yeah, you know, you can see why they've done it. Although it's not right, you can see why. But yeah, I like to put a nice spread on. So we've got the testers out and all the stuff down there ready to go. We've made this bench. This was all that rubbish was dumped in here as well, that old panel. Those bags of rock salt. So we've got all them out. We've had a good sweep up. You probably saw it from the last video anyway, how bad it was in here. We set up the bench, charging station, got testers out. Got this TIS MFT Pro, so I'm going to be using this today. They sent it to me to try out, so that's going to be pretty cool. Get to show you that. And Cam's going to be using the Q-Tech just because it's nice and simple for him. He's still finding his way around testing, so that'll be cool. We'll show you a bit of them. There was also quite a few dodgy supplies that I showed in the last video. So there, Cam's just proving them dead with a proving unit, and then yeah, he's just cutting them out now at the bandsaw. So I'm just going to go catch up with him, see how he's getting on, and we'll start doing a schematic for the sub mains and the sizes and what the lengths are. We'll start pacing them out, and then yeah, we can start drawing up a schematic of what we're basically going to be dealing with, what we're going to be taking charge of when we do this work. Then validate the units individually. Then we'll start designing the panel, and yeah, it's just a prep day really, but I thought it'd be cool to show you that process and how we go about that. We'll go through the RAMs and stuff as well, all the boring stuff, just because it doesn't get highlighted enough, you know. I always show you what I'm doing electrical wise, but there's a lot more going on. There's design, there's RAMs, there's, you know, all sorts of planning that goes involved, ordering, organisation, responsibility, and it doesn't get highlighted on any videos, I feel like, but I'm in a position to do that. So yeah, I'm probably going to try to show you as much of that as I can. So this is the one side of it. These units go around there as well, and then we're going to head around the back of the units here, where this dirty cable was put in and it was tapped off of. So this is one of the joints. So we've got four. This is an alley cable that was ran in. That's the cable that we disconnected when we did the joint in last. And then these are the torpedoes that they've used to then take four sub-mains into here. They've just been cut off inside there. Down here we've got the same thing. So we've got two more joints with four cables just taken into the back of the units, so they're going to get lopped off, and then we've got the further unit down there with exactly the same thing. So Cam's just been through, proved all them dead with a proven unit. We're now going to use a new M12 bandsaw to cut them all, and then yeah, that's that job done. Then we're going to start validating. Just as close to the joint as possible, mate. Don't worry about going that close, but you know, like here. Yeah.
Hold on to like a ripper on it.
Yeah, but you want to use that gauge, that's it. That will stop it bouncing about and keep it. easy as that. So that's actually the new M12 bandsaw. I had to get it imported from America, but it should be out here soon. But I just couldn't wait for it, basically. The old one's pretty good, but that one was just so much better. So I was like, I'm not going to buy the old one when the new one's going to be out in England in like a year or so. And then I just got impatient, basically, and ordered it from a guy through Instagram. But it's still reasonably priced, to be fair. It's got a conduit reamer as well that clicks onto it, so you can cut conduit with it and then ream it with it. It's pretty cool. But yeah, we're going to get all them cut. You've seen the bandsaw now, so I'm not going to show you too much of that. But we'll get all them cut, and then yeah, we'll start validating. Can it handle 4? I don't even know what these are. 25mm alleys or something. It can. Jeez. Yeah, they're like 25mm or something. 4 of them like that though. Right, we'll do the last 4 and then we'll start testing. So these ones, we can't actually see the joints within the back alley, so we're just going to cut them here. But yeah, this was obviously part of what was going on there. Fuse holes and that. So yeah, we'll cut through these, and then we've got to validate all this sort of stuff, which is just in a bad way. Obviously some of this was like UKPM when they just ripped the covers off, test dead or whatever. But what's quite funny is a lot of the units have had these RCCBs put in because these sub-mains are probably failing on trip times because the ZS's will be too high at the circuits. So they've put these, someone's come and put like earth rods in basically on like all of the units, but it's pointless because the sub-main itself, which goes back to the mains, is obviously still not going to trip on time. So although they've put that in so that everything within it is all right, the sub-main's still not protected properly, so it's just all a farce really. Really you want that RCD protection up front by the mains, or you want to select a protective device which is going to accept the value, which we think we could probably get away with BS88s. Failing that, then we're going to have to put in like shunt trip MCCBs, but it starts to get expensive then. But yeah, it's just funny to see every unit's got its own TT, which is probably due to the fact that they're new TTs, do you know what I mean? So they've been put in when someone's done an EICR because the submains have failed, but it doesn't solve the problem of the submains failing. So it was just funny. I'll show you more of that when we're validating, but yeah. Right. So I've started the schematic on the back of this. In the car, mate, is that Vito open tote bag, and in there will be a ruler, a steel ruler, or an engineer square. Could you just grab it, mate? Right, so start drawing out what we think's happening. What are they? 800s? Have to see. Last one, brother. You got that pen? Pencil. What do I do with it? Oh, I've got it here, look. Right, so at the bottom, we've got, what's this called? MP1 maybe? Call it DB1. So at the bottom we've got DB1. It's protected by 2000 amp MCCB. The supply in is to be confirmed, but I think they're 800 singles in parallel, maybe? I don't know, 600s. So that's cool. Right, then off of that we've got power factor corrector, which is going, that's spare. So we've got sheds 1 and 2, DB 1.9, which is this room, sheds 5 to 8, That got cable going to it. Yeah, it's the Shed 5 to 8. It's got a cable going to it, and it's got a cable going to it. So one of them is this cable here, which comes in and gets curled round, goes back down, which is that bottom armoured. So then this top one, that top one must be the supply to unit 3 then, which has been disconnected by UKPN. So DB 1.7 as well. Little single phase board, but that's not being used. Okay, right, so off of it we've got sheds 1 and 2 and office. So sheds 1/2 and office. And that is on a 100 amp MCCB. And that cable size it's looking like 35 mils, but can you, mate, identify this cable at the back here? It should have some writing on it. You can see it here on this side. So you just want to identify what it is. It will be like 3 times 35, 4 times 35. Might have to wiggle it about. Next up, we've got 160 amp breaker, which is spare, but that probably did unit 3. £160 amp MCCB, and that did unit 3 ? Yeah, they're 35s, they're 35s. I reckon they're all 35 mils, mate. I'll have a double check, but I'm pretty confident. I think they're going to be too small as well. Right, so the unit 3 one, mate, you made that 45 metres, you say?
Yeah, 45.
Yeah?
Just
and then, yeah.
So,
and then what we got, 50 metres in here, and then inside the unit itself, a couple of metres.
Yeah.
Call it 55 metres on a bad day. Unit 3, 55 metres. Right, and then those ones over there,
So that one's 67.
67 will allow 70 to get us into that unit here,
Yeah.
75, yeah, to get us round here into the panel, 75 metres. And then that one to the office, so can you trace that? So you know you've got the one that goes through the duct into unit 3.
Yeah.
Yeah, ignore that. One of these gets cleated up the side and along the building and down. Find out exactly where that goes.
Okay.
Trace it through the buildings, and then, because it either goes to unit 1 first, unit 2 first, or it goes to one of them first, and then it's and then when you know where it goes, pace it out. Obviously you got your first 45 metres, so just pace it out from that corner.
Yeah.
Alright? Nice one, mate. Right, so what we've been doing is writing down, obviously you should draw your switches in and all sorts, but this is really, really rough. It's just to get a handle on what's actually going on. So we've got our DB1 here. It's protected by a 2000 amp MCCB. I'm going to identify what these parallels are. Pretty sure they are 800s, but we'll have to double check. Is it written there? I'll have a look. It might also be written on that lug there. But yeah, I'll work that out, and then I think this is saying it's been down rated to 1600 amps anyway, although it's a 2000 amp frame. So yeah, so that's that, and then off of it we've got 4 cables. Once we ditch that power factor corrector, we're going to have 4 cables. One of them's going to units 1 and 2 in the office, one of them's going to unit 3, one of them's going to DP 1.9, which is this little square D KQ in here, not KQ, QO. I was used to Schneider. Square D's been is now Schneider, and they still make these blue boards with the KQ breakers, so I always end up calling them that. Yeah, dog old board, but nevertheless I'm sure it will all test out sweet. So yeah, that's that board here, and then we've got sheds 5 to 8, which is these like lumber sheds here. That's another 35mm, and we make it about 75 meters. So I think a lot of these are going to fail, which is why they've put in, they thought they were solving the problem by TT-ing the units, which isn't a bad thing anyway. Some people might argue that you should TT the metal units anyway, but what that doesn't negate is the fact that these circuits, these submains to the units themselves are probably failing, just because the resistance will be too high for the breaker, this old MCCB, to trip within the required time of 5 seconds. So yeah, they thought they were solving the issue with the earth rods, but they ain't. They've just kept the same issue. So this is this cable here is the one that goes to the steelwork. So that was one we've put in, very, very temporary. We knew we were coming back, so now we're going to cleat it properly, stud it off the wall and stuff like that. I mean, it's supporting itself anyway. Cables that big sort of go where they go. But yeah, we're gonna fix that properly with proper cleats. We had to knock these bricks out to get it through. If you remember, it was a nightmare to do. But yeah, we managed to knock those bricks out so that we could do that, and then sweep it in the side. What's funny is this board is literally just sat on these bricks. It's not fixed to the wall at all. But we wanted to try and do something like that. The reality is you're not going to move that panel. You've got all those armoured set in their ways. It's going to be real hard to move it back and get a fixing on it. Pack out uni and stuff as well will be a nightmare. So it's going to stay how it is. We're just going to try and bung any holes that are in the sides. I know there's a few here. We're going to bung as many holes as we can, some on top, some below, probably using Paxlin and stuff like that. I need to look into it. I keep getting told, but I can't find any information on it, that Paxlin is a carcinogenic. Apparently the resin within it. I'm sure there'd be a lot more awareness on it if it was, and you can still buy it very easily. And I know you can buy lots of stuff that are carcinogenics, but if it was such a big drama that everyone's making out to be, I'm sure there'd be more info on it. Maybe I'm wrong though, but nevertheless, we're going to be using it. So we're going to be cutting it outside, we'll be face fitted, and maybe get some oversuits or something, I don't know, we'll see. But try and be careful with it, because, well, until the facts are in, we just want to be working safely. But it'll be a shame, because I love Paxlin, love working with it, and it neatens up a lot of installs as well. So yeah, we got these schematics out. Cam's just pasting out that last one. We're going to write that on there, and then we're going to try and dead test. It's going to be super hard because we don't really want to work within here. So the only thing we could possibly do is get some gloves on. These are all off, obviously. Get some gloves on and just put the probes in there. I'm probably not going to do it, to be honest with you. We're just going to calc them, because until we can get the panel isolated and work safely within it, yeah, it's going to be very, very difficult. So that's why we're going to pace them out, we're going to calc them, and then we will we'll have all that info, and then unit 3, a lot of the other units, we're basically just going to put in an isolator. They can then do what they want, but unit 3 is one where we're putting in a new fuse board, because they've ripped the fuse board out. So we're putting a new fuse board in. We're going to be getting the lights back on and stuff like that, because loads of stuff was just gutted out. So we need to do a lot of validations there. So we need to make sure that we've got a mute. We're going to make sure that the circuits that we're connecting back up are sweet, basically performing the EICR control on them, on the wiring within there, even though there's no fuse board. And then once they're validated, we can then happily put in a new board. We need to do new contactor controls. We need to make sure all the high bay lights work, chuck in some sockets, a couple of roller shutter door supplies as well because they were cut out. So yeah, there's all sorts to do in there, so that's going to be pretty cool. Probably head over there now because we've got all the info for the cable calcs. I need to ring UKPN, organise a shutdown for this for probably next Friday. That'll work well. And then yeah, get back to the office, I think, and calc all this up because we're not too sure about the tails. So the ZE here is 0.03. This MCCB has a maximum permitted earth fault loop impedance value of 0.04, which means our tails from here to our new MCCB board have got to be 0.01. So Trimble's saying 150 parallels in high tough. I don't get why we can't do 300s, but maybe there's a reason there. Maybe it's the heating factors, or maybe it's the rating of the cable, but I just can't really see why not. But yeah, it's smart software, so it probably knows far more than me. But and we probably will end up doing the parallels anyway, just because it will be easier to work with, especially tri-rated 150s, lovely to work with. So yeah, but we'll get all that info, and then yeah, that'll pretty much be it. We obviously got to do a materials list as well, so maybe I'll try to show you that, and we'll go through these ramps as well. Right, so it goes right to the end one. So where's... He drew me a little map on here, didn't he? So it goes to unit 1, yeah?
Yeah.
And then must go back into unit 2. So it goes to unit 1, we'll circle 1 just to show us that that's the one. And what did you say, 100 and...
Well, 146 and whatever it is.
Call it 150, mate.
150, yeah.
150 metres of 35 mil on a 100 amp breaker. Nah, mate. Okay, so how can we, what we could do to test them is, because the transformer's right there, it's going to be very similar if we test between neutral and earth. They're going to be linked here, it'll be at the transformer, it'll be no different from here, so maybe we'll do that on the ones that are isolated, which is all of them. Yeah, we'll do that. Right, so this sub main, it goes in the duct, but it doesn't come out in the duct. It's this cable here, it's just dragged on there, so we'll try and sort that out. And then it just swoops up into here. And then what someone's done is they've come and put in RCCBs, and then they've TT'd it. But what we're going to do is we're going to disconnect that TT earth, it's all off anyway. We'll test between the neutral and the earth because they'll be connected together back at the mains because it's straight off the transformer, and they are the same thing, TNCS. So yeah, then we should get a rough idea of what we're looking at, because the neutral to the sheath is going to be very similar to phase to sheath, so it will give us a ballpark figure of what we're sort of dealing with, and then we will know, sort of what we're dealing with impedance wise. So yeah, get this cover off and then we'll start testing. To be fair, that earth, they've divorced it here, so that's good. That earth just goes straight to the board. Love a divorce, mate. Cut that out. Oh, we've got to power that roller shutter up, haven't we, to get that in. Yeah, so what they've done here, Cam, is because they've created their own earth, that's what that rod is.
Yeah.
They've created their own earth because this one's probably too high. And also sometimes people do it in metal buildings, because obviously this steelwork goes into the ground here, and yet your earth is all the way over and that mains over there, so there's a potential difference there. So sometimes people like to TT them, but what happens is if you connected this earth in with this one here, because this armoured will be earthed at the panel and connected to that earth. So if they were connected, then it'd be the same earth. So you need to make sure you divorce it. So it comes in here, it's obviously this casing's earth, but then they come out in plastic, they come round into these, and then this earth just goes straight in, so that they're separated. But we want to do an R1, R2, and we can't because that panel's too dangerous to work in. So we're going to do an RN, R2, which should be very similar. So if I put that on there, and that on there, mate, what's the tester saying?
I think it's got sleep.
Oh, that's, yeah, press that button there then, mate. I think I need to update the firmware on it as well. Press continuity top left, and then just press go on there. Go. 0.21. That's not too bad. That's not too bad at all. I thought it'd be a lot worse than that. But this is one of the short ones, to be fair. Okay, so write down that. This is sheds 0.21. 21. Okay, cool. I'll put this cover back on. I mean, this is all fucked anyway, to be fair. Your knees are fucked now?
Yeah.
Aren't you 18, Cam? How was jiu-jitsu? You got fucked out? Did ya? I thought you was going to lay everyone out.
No, well, I did want to show you.
Yeah. How come it was in London?
I don't know, it's for my brother was going because...
Oh, does he do it?
Yeah, he's experienced.
He's experienced.
Yeah.
Who's that, Martin?
No. Fucking hell, if he was experienced, he'd be lethal. No, right.
No, not Ray.
That was good though. Maybe that's self-defence after.
Yeah.
Yeah, for an hour. Yeah.
Right, so the one in this unit here has been locked off at either end. So I'm probably going to chuck the marigolds on and just touch between earth and neutral so that we can get value for that one. I'm quite confident in these now. I mean, it depends what these breakers are saying, but I know the new, to be fair, they probably failed on these ones, but I know the new Hager MCCBs, they're not too bad. Like, if that's 0.21, I think we'll be in. I'm actually in my motor today because since going self-employed, I need to get my own van sorted, and there's just a massive shortage at the minute. Like, I can't get one for love or money. So yeah, I'm using my motor, and then I think next week I've finally managed to sort out a lease. So yeah, that will be good because I'm ruining my car basically, which ain't great at all. So we've got no live working in our rams, but we've assessed that within these side panels with the PPE on, mainly gloves, we're happy with it, and just to not do anything that, you know, not to touch any live parts or nothing like that, not to come into contact with them within close proximity. But I'll try and show you what I'm doing here. It's just to get a result where they've disconnected a cable and left it in the sort of side panel. So alright, that's just it doesn't really verify it, but it just proves there's no holes in it. And then we'll get the over gloves on. So these are, I said in the other video, but I probably should have cleared it up, these are arc gloves. However, these are I'm just using them as over gloves just to protect the rubber gloves. We have got other gloves as well, so when you're dealing with arc, you need to be doing your arc flash calculations, because we've done jobs where these gloves are, so these are rated at 37 cal, I think. 37 cal meters squared, which is the measurement of basically energy when an arc goes off, an arc flash occurs. These have been okay, or they haven't been okay. So, you know, you don't just want to be wearing arc flash PPE without doing your calculations. You really want to show that, because even if you wear it and something happens and then your calcs are wrong, you're just going to get exposed as, you know, not doing the due diligence that you should be doing. But yeah, we're not sort of worried about any of that today. So I'm going to place this on here, and then I'll get this open with these bloody gloves on. Right, and then I'm just working in this side panel here, nothing in there. Basically, we want to stay away from that completely. So I'm now going to grab some of these cables which are disconnected. That's where I'm going to come unstuck, because the neutral is still connected and the earth's still connected, so you should be okay. They've only disconnected the 3 phases, so this is all a waste of time. So if that's still on this neutral bar, which it is, because it's that one there, then that's sweet. So yeah, that's a big old waste of time, but we'll leave it in. This is all footage. But yeah, let's go find Cam. So what was it, mate? 0.29. Okay. Nah, it was. I just realised that the neutral was connected. When I just got my gloves on and everything, done a big song and dance about it, and yeah. Right, cool. Let's go get this last one done then, and then we can give that to Johnny then, and he can start working out what the crack is. We'll go around the back. You can get in the back of that last one, can't you? Yeah. Sweet. Yeah. Right. So same again, bro. Just go between. Look, it has got as well. Look, it has got a little kickstand, so you can do a bit of that. Look at that. Boom. It's a cool tester. I really rate the tester. The only thing I don't actually like about it is these leads. These ones are alright, but I'll show you the plug, and it just seems a bit, yeah, cheap. But the tester, really impressive actually. It's a bit like a Prius. No disrespect to TIS. It's a really good. You press and test. Do you want me to?
Oh yeah, can you press it?
Well, 0.84. That's probably, yeah. I don't think that's going to pass. But yeah, yeah, it's like a Prius. It's a really good, efficient tester. It does everything you want in a really smart and cool way. But no one's going to get excited when you get your TIS out, I think. But
Let the guys with it.
yeah, it's a smart little tester though, and I like the stand on it. It tells you how to do every test on the back. I will do a more in-depth video on it when I do an EICR or something. But yeah, it's really smart. It's got loads of features, loads of data in there as well, so trip times and thresholds and stuff like that. So yeah, you've just got to learn it. You've got to invest in it a bit and learn how it all works. It's also got this little, if I can get it open, this little pen here for the touchscreen, but you can just use your hands as well. But yeah, it's smart. So yeah, what was that, 0.81? Yeah, we'll go through the footage. I think it was 8.1, 8.9, something like that. But yeah, so we've got that now, and then we'll write that down. We'll send that off to the office. We'll also look at that that chart for the trip times for the new MCCBs, and we'll see whether they're going to pass or not. I think the first two might be okay. 2.1 should be okay. 2.9, a little bit high. And 8, that 0.81 is, yeah, way too high. So yeah, but we'll go back now and we'll check. Right, so we're just back at the Love Hut. So this is the MCCB technical data from Hager. These are the MCCBs we're going to be using. So these are the earth fault loop impedance values for 0.2, 0.4 and 1 second. Because these are distribution circuits, we're looking at a 5-second disconnection time. So ideally they want full power, they want, you know, what, at least 100 amps on them. So shed 1 and 2, we got 0.89, 100 amp MCB. It's got a maximum of 0.22, so nowhere near. They're going to get a maximum on these of 0.87, so it'd be 25 amps, which is nowhere near enough to run a, you know, 2 industrial units and the office as well at the front of the complex off of. So we're going to have to look at BS88s for that one for sure. Then we've got this 35mm 4-core, which does unit 3. It's on a 160, which is probably a little bit over rated anyway. But yeah, even if 160 we want to be 0.14 and we're at 0.29, but say if we dropped it down to 100 amps, we want to be 0.22. So we're still not there. And yeah, at 80 amps 0.27, so we're still a bit high. Obviously that was neutral earth, which is through this panel connected at the transformer situated behind this mains room, so there's a little bit extra resistance there, but like the ZE at this board's 0.03, so you know it's not a lot really. It's going to be pretty much there or thereabouts, so that's going to be a tough one. But the shed's 5 to 8, 0.21, I think we're in 0.22, so I'll just speak to the guys at the office, see if they're happy. They might want to drop it down to an 80, just to be 0.27 to not be so close to the mark on that one. But yeah, that's why we validated it, so that we could sort of make sure what we're doing is okay. What's funny is, like I say, that one's probably all right, but these other 2 units, they put them on TTs with RCCBs, probably because of that reason, but it's not going to do anything. They're still not protected properly because the RCD's over there and not here where it needs to be. So yeah, we're going to ring that through to the office. I'm going to try ring UKPN as well, just because while it's early in the day, probably be better to try and get hold of them now. And then we're going to start probably drawing out what we're going to do with the board in here, writing a materials list. Then that's pretty much it, apart from going into unit 3, doing some further validations on the actual circuits within the unit, and getting a materials list together for all the bits we need to get that up to scratch too. So yeah, probably going to go get some lunch as well, so we'll do all that and we'll catch you in a little bit. Right, so we're in unit 3 now. We've got most of the stuff we need for the mains. Just having a recce in. I'll get the materials list together for the works that are in here. Try get some test results and have a little look up top what we're dealing with as well. This board was completely just ripped out, so they come in, cut the board out, and then yeah, cut all the circuits out up top as well. So we're probably going to bring this cable through lower down to gain a bit of slack, mount a new board, just a Hager 3-phase board in here, put a contactor box up the top. Most of these lighting circuits we're going to reuse, so that's where our contactor box is going to go, and then we can extend them down into the board, and that should be sweet. We've also got to run in 2 roller shutter door supplies, a contactor control circuit for the front door, and a little power circuit as well. So it's probably just going to be G-clamps and stuff like that for now. They don't want any containment in there as of yet, so we'll just clip them round. So yeah, we're going to get a materials list together, and then we'll start validating or trying to validate some of these lighting circuits, but we might leave that for next week because that's what we've got planned for next week. It's just if we've got time, basically. So yeah, we'll get cracking on that now. Right, so far roller door, 85 metres. Contactor control will be the same then. And that one, We're saying 5 metres between pillars, 5, 10, 15, 20, 5 up, 5 down, 35 metres, 40 metres. Yeah, 40 metres. So that's that. So contactor's going over there, so that'll be the same as that one. So we've got to put in 2 roller shutter door supplies in this unit, a contactor control light switch over there. We're probably going to renew the outside lighting circuit as well. So that's probably, that's 85, 60 metres outside lighting. Lighting L2G, so that'll be again 60 metres. So we've just paced them out because our board's going in this corner. We're probably just going to do G clamps, which is going to be fun, but they don't want to have containment, so it is what it is. Cam's just jumped on the mute, harnessed up with the lid on, just to have a look at these roller shutter door supplies. So at the minute there is supplies in, but everything seems to be really undersized. So we're just looking at the motor ratings on the roller shutters. It won't be a lot, but over a distance, we might end up doing it in 4mm or something like that, rather than the 2.5 they've banged in. So yeah, he's just going to verify them. Then we're going to maybe just look at this lighting. It looks like they're all right light fittings. There's sort of clicks roses just above. It's all done in NYY, and then Beezer boxes with clicks plugs and roses down. The only thing we've noticed is the connections are just connector blocked on. Obviously you've got a pre-made flex on the light, and then you've got the clicks rose, and they've just put like connector blocks up there. So we treat cables visible outside of an enclosure as a C2. It's just what we do at BES. So we're going to have to, although it's out of reach, we're not using that as a method of protection. So we're going to have to jump up there and basically put Wago boxes around them. I think the shorter ones around the edges, obviously the clicks, they're pre-made clickses and they were long enough to go, but the ones in the middle where they get a lot longer, you can see like the connector blocks just halfway up the flexes. So we're just going to put Wago boxes around them just because it's just a quick fix to tick the box really, get it compliant. And then yeah, board's going in this corner. So I just need to speak to the office how much, because obviously we're only going to be banging in probably 8 circuits or something, but you know, you want to give the capacity of a full industrial unit and give them this unit, they'll be having 80 amps or 100 amps. So whatever they have, you want to give them enough space, future-proof, to do that justice. So going to see what size board we need. I'm going to start counting up the contactors as well. We need to work out how many lighting circuits we've got too. So this is just all the sort of stuff we're doing today, and then we can hit the ground running next week. I'll be off Monday, but Tuesday to Friday I'll be here filming. Like I say, it's going to be a few videos, might even be like a series or something. I'll try and show different objectives every day or different tasks or whatever. Just because otherwise it might get a bit boring. But yeah, we'll do like a video on this board, we'll do a video on the high level lighting, video or 2 on the main panel, maybe do a containment video and a panel video or something. So yeah, UKPM will be coming to isolate as well, so that'd be cool to show all that. But yeah, at the minute we're just doing all the wrecking. Cam's up there, checking that one out. How's it looking, big boy? So I just thought I'd show this. So this is the case the MFT Pro comes in. Real nice case. Software on the discs. You get the strap, which is really weird actually. It sort of like clips around your waist as well, I think. I don't really rate that. And this is this lead, which again, like, it's all right, you know. There's a bit of like Helaman or heat shrink around there. You've got your 3 plugs that go into your tester. And then you've just got like a normal plug and the sock round it. It's just, yeah, you know, compared to other testers, it just seems a bit cheap. But apart from that, these leads are fine. You actually get little dust caps for the leads as well. You know, the croc clips are decent, the probes are decent. What's in here? I guess that's for like an update or something. It's like an optical cable. Not really too sure on that. But yeah, apart from that, it's a really good tester. It's got loads of functionalities on it as well. I'll just turn it on and just show you. Like I said, I'll do a full video on it, but it'd just be cool to show you. I think I need a software update. But yeah, so you can save all your results. Right, battery died on the GoPro. But yeah, I'll do a fully featured video on it. But the long and short of it is it's a really impressive tester. A few things could be better, but the same with all testers, they all have their downsides. And to be honest, it's a real, there's nothing wrong with the tester itself. I actually really like the way it works. I like the design as well, how it's a bit different than your usual tester. I like the little stand too. So yeah, the strap leaves a little bit to be desired, and most of the lead's okay. It's just, yeah, you know, that one's just a little bit, there's nothing wrong with it, you know, there is really nothing wrong with it, like it's sweet, but just compared to your nicer moulded leads, you know, but that's more of a nitpick than anything. But yeah, it's a decent tester. I will do like a full video, or I'm trying to stay away from the product videos because I don't think you guys find them too interesting, but I will use it for like an EICR or something, or maybe I'll do all the testing on this job with this, and then we can get to know it together sort of thing, and show you how it all works. So that'll be pretty cool actually. I think I'll do that. Cam is up here. We're struggling to find, we're looking for a rating plate basically. It's not going to be a lot, it's the tiniest motor in the world, but we're just trying to see what sort of load we're looking at for them, but we can't really tell. There's no sticker on it or nothing. I think that's the motor this end, mate, to be honest with you.
That's where the cable goes in, but it's just, there's nothing on it.
Yeah, it might be where that plate's bolted onto it is blocking it. But where I've taken those plates off before, they're like the spring of the roller shutter is in there, and it's a nightmare. You don't really want to get involved with that, but it's only a tiny little flex, isn't it? Oh, this is so gash. That's just a little key switch, isn't it? Yeah. That's it. And then that pushes these contacts, must do. Yeah, pushes those in, on, up and down. Okay. Well, it was on a 13 amp plug before, so I guess if we put in like a, we'll just put in like a 2.5 or a 16 amp circuit and put in a fuse spur next to this switch, and that will do that. We'll do the same for that one. So 2.25 circuits, 2.25 circuits, 2 16 amp circuits, and then we'll be looking at a 6 amp contactor control, 10 amp outside lighting circuit at those meterages. So I'll see what they come out as on the calcs. And then can you just boom up, Cam, and just have a look at these lights, get a load of pictures of them. Do one from each section. So don't do that one there, then do this one, and then do this one, because where they're at different heights, they've cut the leads and stuff, I think. So just check, because like that one looks like it doesn't need a Wago box or nothing, by the looks of it. But yeah, get a load of pictures of the wiring, the beezer boxes and stuff like that for us. Cool, after that we're pretty much done here, to be honest. I need to find out the capacity of the boards, like I said, so I'll do that. And then, yeah, we're pretty much thereabouts. Start working out these contactors. That's the only thing. I need to see how many lighting circuits there are. There's 8 cables, 1 for each roller shutter door, 1 for the socket circuit, which is radial. So it's looking like 5 lighting circuits. There's 25 lights, 5 lights on each circuit. That would make sense to me. And they come from that direction. Ah, yeah, I think they've done them that way. So like that's 1 circuit, and then they come along, 1 goes up. No, it's not how they've done it. So that one comes along from there, goes in and out. There's also high level sockets, so that's what might be what some of those cables are. Then it goes in and out of there, then back down this steel. I think what we'll do is we'll get the Jenny in, basically. We'll get the Jenny in, we'll test to make sure that the circuits are safe to be energised within reason, some insulation resistance and some continuity tests. We'll get the Jenny in next week, we'll just buzz them on one by one, and then we'll know, all right, that's 5 of them, that's 5 of them, that's 5 of them, just to save us loads of ag. with belling stuff out and all that sort of thing. Might still have to do that depending on if these lights work, but they look like LEDs. They look quite new. They look haggard, but they look quite new, so hopefully that's the case with them. So yeah, I think that's my plan for that, but I'm going to assume 5 lighting circuits. I'm going to allow for that with the order and the contactor enclosure. So yeah, we'll just wait for Cam to get down after doing that, and then we'll get a list together for the mains. I'll speak to the office, and then we're probably going to get out of here, head back to HQ with all the info we've got today, start getting a plan together for the next couple of weeks, and yeah. I'll probably outro the video before we go, but yeah, we'll see. Right, so that is us all done for the day. So we just got to ring a massive order through, look at lead times and stuff like that. We're still waiting on some info on like the main switch on the board, if it can accept parallel 185s and stuff. It should do, but we just need to make sure everything's sweet before we commit to it. So yeah, we're gonna leave now, order all that up. But yeah, before we do, I just want to show you this mains room. So I thought I might have showed you earlier, but we're all sort of set up in here now, so that's all good. We've had a good sweep out, cleaned the mat off, and just gave it, you know what I mean, half hour tidying, and look how much better it is. Yeah, this is the plan with this board. So we're going to come out of there in some 6-inch trunking, on some uni, across, round there, down, across again, back up. And then the board is going to sit in the middle of that. It's got an expansion chamber for the meters, probably going to put that on the left-hand side. Until it's all here, we'll get it sized up properly, but we've got a few rough measurements. These sub-mains are going to get stripped out, sent up some tray on the external, core hold through, along and into the trunking, glanded off, down and in. And then we'll put some cleats around this, just to, now it's not temporary, I mean it's set in its ways anyway, it's not going anywhere, but put some cleats around it and tidy that up, just because it is going to be a permanent fixture now. And then yeah, we've obviously got loads of work to do in that other unit, Unit 3. There's loads of content here, it's quite exciting actually. Probably get, you know, a couple of videos, mute video, high level sort of power video, and all that, and then the board and all that in that unit, and then probably get 2 videos here, you know, a day prepping it all and all that, and then a day with the UKPN shut down and putting it all away, so that'll be cool. Try show you more of the behind the scenes as well, the RAMs. I didn't have them to hand today, but I've got them on my phone, but it's not the same. But I want to go through the RAMs, show like how stuff like that works with us, more of the process side of stuff, just because it doesn't get highlighted enough, you know, especially all the health and safety and stuff like that. And I do have a bit of a duty of putting this stuff online to show, you know, the processes and thoughts involved with all of that. But yeah, just going to try do that, as well as show you loads of practical stuff. Try not to show you too much. Sometimes I feel like I might show too much as well, when I shouldn't. But yeah, just find that sweet spot. It's all very new to me, and I'm just enjoying it more than anything. Try not to think about it too much, but maybe I should. But yeah, that's pretty much it for today's video. Thanks for watching as always, guys. If you haven't already, please like, subscribe, hit that bell button. Really supports the channel, what I'm trying to do. And yeah, I'll catch you on the next one.